Hello, my name is Michaela Harris, and for today's video and today's topic, I'm going to be talking about force load and pressure sensors. And I bet you are wondering, what are force loads and pressure sensors? Basically, force loads, sensors, and pressure sensors are type of transducers that measure mechanical forces and pressures respectively. When it comes to force load sensors, those sensors are mainly used to measure mechanical forces such as like tension, compression, or shear. And once they measure it, they basically convert it into electrical signals. When it comes to pressure sensors, basically those sensors measure fluid or gas pressure, which is basically force per unit area. And with them doing that, it basically converts the fluid or gas pressure into an electric signal. Both force load and pressure sensors are crucial in automation, robotics, automotive, and industrial systems, but they serve different physical measurements. And in this section, we're going to talk about the purpose and function when it comes to a force/load sensor. The primary purpose of a force load sensor is that one, they measure applied force, which is basically it quantifies how much force is acting on an object, such things like weight, impact, and thrust. And then the next one would be monitor structural loads. Basically, it's ensuring machinery, bridges, or vehicles operate within a safe force limit. And then for the next one up is the control automated systems, which it basically provides feedback in robotics, manufacturing, and aerospace for precision handling. Then they can also test material strength, which is basically using tensile testers, compression testers, and fatigue testing machines. And they can also help improve safety, which is basically it can detect overload in cranes, elevators, or medical devices to prevent failure. Now we're going to talk about some of the functions that comes with a force load sensor. First one being force detection. It basically, as I said previously, it converts mechanical forces into a measurable signal, things like a strain gauge, change force under load, and with that load sensor, it basically enables closed loops controls in sensors like a robotic arm, industrial pressing, and also medical devices. And in this section, we're going to be talking about how do force load sensors and how do they work. Now, the most common ones that they use is basically a strain gauge based load cell, which is the most common type to use. Basically, the principle is that it measures tiny deformations, which is basically strain, caused by force, which then changes electrical resistance. First, it does a force application, which is basically external load, such as weight, push, and pull, that is applied to the sensor. Then next up is material deformation, which is basically the sensor metal or semiconductor element bends slightly. And by doing that, it causes a strain gauge resistance change, which is basically when the strain gauges are bonded to the deforming surface. And also when it's stretched or compressed, their electrical resistance changes. And then the next one being is a Wheatstone bridge circuit, which is basically multiple strain gauges are arranged in a bridge configuration. The resistance imbalance creates a small output of voltage, and with it doing that, it makes a weak analog signal that is amplified and converted into readable output signals, such things like digital displays or PLC inputs. Here's something to basically give you a visual understanding of what that means. Is basically, let's say you have a bathroom scale. A bathroom scale uses a strain gauge load cell to measure weight. That's basically a visual of what I'm saying. And it can also use other force sensors like hydraulic and pneumatic cells. Use basically magnetic force sensors and capacitive sensors. Yeah, it can basically use a lot of sensors basically to get a signal output. And for this section, we're gonna talk about the components, all the components that come with a force and load sensor. The first one being is a strain gauge, which it basically senses deformation within the sensor. And then the second one being is a Wheatstone bridge, which basically it converts resistance changes to voltage. And the third one being a load cell, which is basically a sensor housing with multiple strain gauges. And then for the last one, which is basically a signal processor, which it basically amplifies and converts signals to a readable output. Now, there are more components that comes with a force load sensor, which another one being is a signal conditioning circuitry, which is basically boosts the weak voltage signal for processing. And then you have the housing and protective components, which is basically use seals and O-rings, which basically it protects against dust, moisture, and other chemicals, which kind of help prevents damage from excessive forces. Now there's other more components than that, but we're just gonna stick to the main four that is needed for a load sensor. And in this section, we're going to be talking about all the applications that can be used for a force/load sensor. The first one being, which is a weighing scale. Now, this can vary to a various of places, like the weighing scheme in your bathroom and weighing scheme that's used in industrial industries. Basically, stuff like truck scales, conveyor belt weighing, hopper, and batch weighing. And then for the second one being, which is basically structural health monitoring. Basically, they mean things like medical scales, such as things like patient weighing monitors, hospital beds, and wheelchair scaling. They also use it for prosthetics and orthodontics. Basically, what they do is that it analyzes the pressure distribution in a artificial limb, and they also use this for surgical robotics, which is basically it force feedback in a minimally invasive surgery. And they also use it for physical therapy, such as it measures muscle strength and rehabilitation progress. And they can also be used for robotic arms, basically things that you see mainly in car plants or mainly in the manufacturing industrial space in general. And they can also be used for automotive crash testing. Now, what it mainly is used for is automotive and aerospace, which is basically they monitor the stress during takeoff and landing, and they also take measurements of the jet engine that stands. Basically, when it comes to a force and a load sensor, it can basically be used for variety of places and industries, like multiple applications that you can use this for. Now we're going to be talking about the purpose and function that comes with a pressure sensor. Basically, what a pressure sensor is that it is a device that measures fluid or gas pressures and converts it into an electrical signal for monitoring, control, or data analysis. One of its main purpose is that it measures pressure, which is basically it detects absolute, gauge, differential, or vacuum pressures, Second one being is it monitors system performance. It ensures machinery operate within a safe pressure limit, and it also enables automation. It provides feedback for control systems, and it also can improve safety, which basically prevents overpressure in pipelines, tanks, and medical devices. And it also enhances efficiency, optimizing process in industrial, automotive, and aerospace systems. Now we're going to be talking about how do pressure sensors work. Basically, as I've already said before, basically pressure sensors work by converting a physical pressure measurement into an electrical signal. This is typically achieved by detecting the force exerted by a fluid. It can also be liquid or gas on a sensing element, such as a diaphragm, and then converting that force into a change in electrical resistance, capacitor, or other measurable properties. And here is all the components that comes with a pressure sensor. The first one being is a sensing element such as thing as a Bourdon tube, bellows, or a semiconductor. The second one being is a transducer, which basically converts mechanical motion into an electrical signal. And the third one being a signal conditioning, which basically amplifies and formats the signal. And the last one being is a display or interface, which basically it shows pressure readings or it can also send data. Now we're going to be talking about the applications that come with a pressure sensor. And just like when it comes to a force/load sensor, it can also be used for a variety of things. It can be used in industrial and manufacturing industries, such things like hydraulic and pneumatic systems, things like monitor pump, compressors, and actuator pressures. It can be used for process control, such as oil refiners, chemical plants, and water treatment facilities. And they can also be used in automotive and transportations, basically tire pressure monitoring, engine management, and fuel systems, brake system, exhaust gas, recirculation, airbag deployment, and a variety of other things. And they can also be used in the medical and healthcare, basically blood pressure monitors, ventilators and respirators, infusion pumps, prosthetics, and anesthesia machines. And it can also be used for aerospace, basically aircraft cabin pressure controls, jet and rocket engines, flight control systems, and the spacecraft itself. And it also can be used by consumer electronics, such things as smartphones and tablets, wearables and smartwatches, vacuum robots, and voice assistants. And even the weather stations use pressure sensors to detect the weather, basically how much rain is going to be. And they also use it to detect flood warning and also air quality. So basically, in conclusion, force, load, and pressure sensors are essential in translating physical parameters into measurable electrical signals. They enhance automation, safety, and efficiency across industries. And also understanding their working principles and uses is crucial in control systems. And these are my references. I hope you enjoyed this video. My name is Michaela Harris, and I'll be talking to you later.